Thank you. Thank you. Hey, everybody. I'm Adam Sullivan. I'm the Executive Director of AI for Labcorp, and hoping to talk a little bit more today about everyone's favorite word, generative AI, right? You've heard it so much at the conference today. Um, but really want to share some of the work that we're doing at Labcorp, being practical about generative AI. So we're not going to talk about the future state of generative AI and all the crazy things that it can do. We're going to talk about how we're actually using it today. Um, First and foremost, always like to highlight that we have an amazing team of data scientists at Labcorp. Um, they are, a lot of different backgrounds, a lot of different skill sets. They come from many different, industries, and we're able to leverage that to do some really amazing things at Labcorp in pursuit of our mission. Really, any one of them could be working at a really amazing, data science team, and they've chosen to work at Labcorp because they do really truly believe in using our data and our skills to improve health and improve lives. So it's a really amazing team, and very proud of all the work that they do over and over again. So we have, within our, where we're going with AI in general across our company really buckets into three areas. The first one is that we think that we can use AI for optimizing our revenue, maximize profitability. And really that's thinking about all these things that, we think about revenue cycle management, and we think about all the supplies and ordering that we do. If we can use AI to be more efficient in those areas, that's one of our key pillars. We also think that, Labcorp being, so wide across the country in terms of the breadth and depth of data that we have, we can use our data to do things like look at, can we identify patients that might have chronic kidney disease or NASH or other diseases based off finding hidden signals in our biomarkers and the lab data that we have. We really think that we can make a huge difference in the lives of our patients. And then finally, and we're thinking about this a lot from the generative AI perspective, we have a lot of things, when you process, millions and millions of specimens per month that are very critical to people's health. There's a lot of things that happen that are very repetitive, from data entry, reviewing forms, going through claims submissions and processing. So if we can and there's no shortage of things for us to do as we're trying to work through, the chain of custody of a lab specimen to getting the result. But we can use AI, we are using AI to, identify areas where we are spending a lot of time doing very repetitive tasks, and change that work dynamic so that people are focused on the exceptions, the hard cases, the things that AI can't handle, and really just change how, our value stream across the entire spectrum of work that we have to do. So this really is, we've worked, we've done a lot of work being very intentional about how we want to go after our AI strategy, and it really everything we do kind of buckets into one of these three areas. There's a stat recently that 80% of C-suite executives are bragging about the AI that they're using, and it's something like 54% of employees with boots on the ground employees can actually say anything of where they're using AI. And so the cool thing about what we've done at Labcorp is that we really have adopted AI across our business area. So Labcorp, we have so many different functions. Obviously people know Labcorp for the diagnostic testing that we do, but we also have a central lab that focuses on clinical trials. And we also have an early development lab that focuses on clinical trials. And so we have AI models that are, identifying we're using AI for forecasting our free cash flow as an example. We have AI models that are within revenue cycle management. One in particular, we actually have a reinforcement learning model that is changing how we invoice our patients so that we can meet patients with a text message or an email at the right time, at the right, with the right content. And that's had serious changes in our ability to collect within the RCM space. We have models that are monitoring the health of primates in early development. We've models in central labs looking at, the kits that go out, the lab kits that go out, and the lab kits that come back. And if you're in one of our patient service centers, typically they're embedded in Walgreens. As you're interacting with the kiosk, we have AI that's being used there. So there's a lot of different areas across the board where we've actually deployed AI, and it is making a meaningful impact within our business. One of the things that we're very proud of is that we've worked with our compliance team to create an AI ethics framework. And there's an AI ethics committee that reviews high risk areas where we might be using AI to make sure that we're doing the right thing. But we've modeled our ethical framework after the U.S. White House AI Bill of Rights. And that's really safe and effective systems, algorithmic discrimination protections, data privacy, notice and explanation, and human alternatives consideration and fallback. The latter two are actually really interesting, and we hadn't really thought much about that. But what it really means, and the intention of the way they've worded it, is that whenever you're using AI, if somebody is experiencing an output that is driven by some AI engine, that the person who is interacting with that should know and be trained on when to identify that maybe something is wrong and it's not doing what it should be doing, and have a way to raise the red flag, whether through a help desk ticket or a phone number or an email address or something, but really train people that are, end users of AI so they know what to look for when something might not be right and they might be seeing bias or whatever else. So that was one of the, big areas that we, as we kind of went through the journey of creating this, that really gave us some pause to think about. So I want to talk little bit about our generative AI use case. And at this point, we probably have 7 or 8 generative AI models that we are using across our business. And we are using them generally on Bedrock through AWS. And we've been happy with the model output that's been there. But one of the main challenges that we have is that there are, and all the lab businesses are doing this, but we are partnering with many different customers to bring in their labs into Labcorp. And the challenge we have is that on one side, so the hospital that wants to partner with us, they have thousands of labs that they run today, like thousands of different order codes that they process today. And then on our side, we have thousands, tens of thousands of lab tests that we offer. And you have to do a one-to-one match so that if this hospital is doing an A1C test, it's got to match our A1C test. But then it gets more complicated. If you're doing a genetic test, the genes have to match between the two. And if you're doing a panel, the panel components have to match. If you're doing toxicology testing, the thresholds have to match, the cutoff thresholds of the detection. So, and what's interesting about this is on our side, this information is known by 10 or 15 people really well. So you think about the skill set of somebody that could do this matching, right? They have to be very good at knowing all the medical and clinical terminology of testing. But then also they have to know how to use our mainframe and navigate through all these different test codes we have. So we realized that skill set is something that would be really good for a generative AI model. And really what we're talking about is we have a customer's lab compendium and we have our lab compendium. And the goal is that we need to match those for thousands of tests. And we're doing this multiple times a week. This represented a pretty wide, long pole in the tent is we're trying to onboard a customer because somebody has to do this. And there's only, like I said, there's probably only 10 people in the world that can know lab tests and be able to navigate a mainframe to get all this data out. So our team went through and said, all right, how can we prompt engineer and fine tune a model to do this task that these people do today? So I'm going to give you an example. This is a real test that we got from a customer, 17-hydroxypregnanolone quantitative by LC-MS MS serum. Anybody know what it does? What you do? I think it's a test that's used for identifying early puberty, and but it's a lot of syllables that are that are contained in there. Um, so out of the gate, we don't have anyone that would be a good test code matcher in our business. So what we did is we leveraged Bedrock, and that's where Amazon's hosting their generative AI models. In particular, we're using Claude, and the what we did was our data scientists sat down with the people who do this test code matching today and said, what do you need to think about whenever you do a successful test code match? And our model, what I'm going to show you next, is real output from a generative AI model that actually is able to properly do this match. The first thing that happens is that we do, if you've heard some of the terms of generative AI, the first thing we do is retrieval. So we have a background system that is cataloging all the information about our thousands of tests that we have. And so the first step that happens is kind of like a Google search, where it's like, let's find the top 10 tests that might match this, and then we're going to feed those into our generative AI model and say which one is the most appropriate and why. So what I'm going to show next, again, this is real output from our generative AI model. This is not something that I created. This is what we did through prompt engineering to tell the model to do what we wanted it to do. And so at first, the model actually goes through our thousands of tests and says, hey, actually, we have one test that kind of looks like the one that you just mentioned. We have a test called 17-hydroxypregnenolone mass spectrometry, endocrine sciences. So the model's picked up on a candidate that it thinks might be the most appropriate test. And then through prompt engineering, by learning what those people do within our team today, the model looks at the methodology between the two tests and says, hey, the first test uses high performance liquid chromatography tandem mass spectrometry, and the candidate test uses the same methodology. So the first thing that they do whenever they look is say, do the methodologies match? And we're good there. The second thing that they go through is that they look at the specimen type, and sure enough, both tests use serum or plasma. The model then looks at the volume requirements, and so the target test requires two 0.5 ml tubes, and the candidate test requires a 1 ml tube. And we actually wrote through our prompt engineering that as part of that matching exercise, that's an acceptable match. So two 0.5s, as long as it adds up to one, we're good. So the model met that criteria. Both tests require freezing, so we're good on the temperature requirements. Both tests have the same CPT codes, which is important because we need to get paid for the tests that we offer. And then finally, the model then goes through and says, hey, the candidate test matches the target test methodology, the specimen type. It has a similar volume, storage, and turnaround requirements. Therefore, I'm very confident that these two tests are indeed the same thing. And if you think about, this is a human that did this previously, and now we're able to run a first pass where the model is repeating this over and over again in a matter of a few seconds, and not, you just imagine the time requirement and the skill requirement to actually do this, that we were able to take that logic that a human uses today, replicate it in instructions in an LLM, and be able to match this really complex test to the same criteria that we would have for what we do today. So, and really, it is, we talk about, if you've heard the phrase RAG, retrieval augmented generation, that's the, what we're, the basis of how we're actually doing this. And there's a lot of different ways to implement it, but the key point here is this, the knowledge source is up in the top right, and that knowledge source there is our lab. Those are our labs that sit, the order codes and the test codes that sit in our mainframe that describe all these different tests that we have. We have a lot of other generative AI models that we've built from, we're trying to do data entry more efficiently. We have models that were built for trying to identify denials and, using generative AI to say not just what has been denied, but why, and do we actually agree with why we've been denied? We've built models that are generative AI use cases that are trying to respond to patient emails, and a whole slew of other things. So there's a lot of really good potential from what we've seen from this technology so far. It's not a black box by any stretch. I think a lot of times, we see these presentations. It's like, oh, you can just dump everything in Chat GPT and it's going to do the work for you. I actually think there is quite a bit of skill in the team that I showed earlier that drives our ability to answer questions like the one we just showed. But the one thing I'd say is that really the technology and the skill set here is, a year old, right? Like, if we think back a year ago, we had, the introduction to Chat GPT. Prompt engineering wasn't even a skill set that people talked about. And so I think anyone can get into it and deliver on it, but it does take some skill and talent to figure out how to do it in problem solving. And the team that we've generated has just been great overall. So I do want to thank everyone for showing up early. I know that I was the highlight of your show. I appreciate it. But we do have some time for questions. But thank you all very much.